This is Additive Manufacturing Lecture 6 B. So we are talking about some of the resin formulations and reactions and things like that. So the basic raw materials can be different kinds of acrylates or polyols or uh, epoxides and things like that. And they are used to produce the monomers and oligomers used for radiation curing. And the monomers themselves are multifunctional monomers or polyol polyacrylates which can cross-link. So essentially, don't worry about the exact chemical composition, but just understand that they are multifunctional monomers that can cross-link and create a strong polymer. And these oligomers can be um, chemical families that contain polyester acrylate, they call it PEA, or epoxy acrylates or EAs, or urethane acrylates or UAs, or amino acrylates. And these oligomers are used as a photoaccelerator in the uh, photoinitiator system and cycloaliphatic epoxies. But most of the time, we don't worry about that because the resin suppliers just supply the ready to use formulations. And um, the sometimes it comes as a two-part or a three-part formulation. So you just mix them and with a photoinitiator as well as other materials to affect reaction rates, and then you just uh, you might have to add what are called photosensitizers that can combine with the photoinitiator to shift the absorption towards longer wavelengths. The reason why we want longer wavelengths is because they have lesser energy, which means that people who might get exposed to it by any chance might not get uh, affected by it. I mean, longer wavelengths will, suppose you put your hand below that laser beam, it's not going to affect you. But suppose they were shorter wavelength, that shorter wavelength can penetrate a larger distance into your skin or your body. These supporting materials may be mixed with the initiator that will help you to get the right kind of solubility in the formulation. And you can also have combinations or different types of photoinitiators depending upon the application. They are typically, the photoinitiating systems are typically very elaborate mixtures of various compounds, and you don't worry about that. You just take the materials and just add them together to make the final combination. You could also have additives to the photoinitiators so that you get good properties. So you might want to reduce the shrinkage, or you may want to get good mechanical properties. And you may also want to have a reactive diluent to adjust the viscosity of the mixture. So so that when you spread it um, on the top on the layer that has just been built, it gives you the right kind of viscosity. It doesn't just fall off, or it doesn't stick around and clump up at different corners. It will also participate in the polymerization reaction. So what is the role of the photoinitiator itself? It is to convert the physical energy of the incident light into chemical energy in the form of reactive intermediates. And it can exhibit a strong absorption at the right laser emission wavelength and undergo a very fast reaction to generate the initiating species with a large yield so that you can produce the part in a very short time. Now, many of these are benzene, benzoin ether derivatives, hydroxyalkyl phenones, aminoketones, or acyl phosphine oxides. Now, I can understand that you may not exactly understand what these are, but just realize that you have a combination of photoinitiators, monomers, etc., that are blended in the right proportion to get the right kind of properties. In the case of some of these earlier resin systems, they were made by Ciba. It used to be called Ciba Geigy, but it became only Ciba, and they were some of the earliest producers of the stereolithography resin systems. And I believe that it might have been taken over by 3D systems. Now, the takeaway from this is that these photoinitiators should be able to initiate the radical polymerization, and it can initiate the polymerization reactions among the epoxy molecules so that all the epoxy molecules are linked together to form a very strong chain. The monomer by themselves, they are from a set of patents from the mid to late 1990s. And there are many of these monomers that are used in typical stereolithography resins. For example, there are polymethacrylates. They are tripentafunctional. Um, sorry, these are a lot of things here. By the way, one of the other manufacturers of these stereolithography resins is Huntsman. Huntsman is a very, especially the ones that contain the epoxy type of combinations are all made by Huntsman because they are very strong in epoxy chemistry. I'm sorry, there are a lot of a lot of information here, chemical information here.